In this session, we will analyze a continuous beam using StatPro VATI software. Now let us open this StatPro VATI software. Click on New Project. Select Plane as we are preparing a 2D model. Give the file name as a continuous beam. So where to store this one? We can choose the location here. Click here. On desktop, in CAD file, I am storing it in continuous beam. So path is chosen for the continuous beam. Care should be taken that the unit should be in terms of meters and kilonewton. Click on next. So here we have add beam, then click on finish. Okay, this is the name given for your file, that is a continuous beam. So this is the grid. We can either model by using this grid system or node system, or directly we can import an AutoCAD file to our StatPro software. So in this session we will prepare by using nodes. So I will close this grid system. So to start with a new model, our model should be at 0, start from 0, 0, 0. So this is your UCS showing z-axis, x-axis and y-axis. So your node should start from 0, 0, 0. So that's why I am defining here 0. Okay. Now I will save this node. So this is your continuous beam which we will be analyzing it in this session. So this beam is of having spans of 4 meter, 6 meter, 6 meter, having a section modulus of moment of inertia equal to I, 2I and 1.5I. Using this value we can find out or we can fix up the dimension for your beams. So here 64 kilonewton is the concentrated load, 45 kilonewton concentrated load and 12 kilonewton meter of UDL is acting over this beam. So this is the shear force. So this is the bending. This is the shear force diagram developed for this beam by analyzing it manually. So in this session we will compare the manual values with whatever the values we are getting from the StatPro. So as you can see here, the first beam length is of 4 meter. So what I will do, this node can get only selected only when the cursor is set for node cursor. This is your node cursor. So select this node cursor, select the node. Now hold your control key and press C, and then now press control and V. So this dialog box get opens here in x direction at a distance of 4 meters. Okay, so here one more node created. So these are the different views. So this is a positive view from positive z axis. This indicates this is a front view. So I will keep it in front view. So you can see here, this is your xy plane now. So now the next beam is of length 6 meters. So select Ctrl C, Ctrl V at a distance of 6 meters. Okay. Now next again your last span is also of 6 meters. So again select the node, Ctrl C, Ctrl V at a distance of 6 meters. Okay, so now these are the nodes are created. Now I have to add beam member here. So I will go to geometry, add beams, add beam from point to point. So now your beam is ready. Now what we have to do is we have to assign support for this beam as shown in the given problem. So all the supports are simply supported. So what I can do, I can go to click here, general, here there is an option called support. Click on that, click over create. Here there are different kinds of supports are given. One is fixed, another one is pinned. In fixed, all the all the six things are restrained, that is Fy, Fx, Fy, Fz and moments Mx, My and Mz. All the six parameters are fixed, are restrained here. In pinned, this, that is for simply supported, what happens, there is no moment is 0, so moment is not restrained there, so only Fx, Fy and Fz are restrained. So I will add this support. Now what I will do, I will select this support, I have to assign. So there are different methods to assign your support to this beam member. So assign to selected node, assign to view, assign, use cursor to assign, assign to edit list. Okay, first I will show use cursor to assign. So you can select this one, then tell assign. So you should assign like this. Okay, wherever you had nodes. So what had happened here, you cannot see the nodes. So what I will do, I will press escape, right click here, then go to the labels, node points, click here, apply. Okay, so now you can see your nodes. So what I will do, again assign, so I can assign them easily. So otherwise second method is, you can go for select this one, using node cursor, select the nodes and here press assign. Supports got assigned here. So now next thing is to assign loads for these beams. So where will I go? So go to general, loads and definition, here load case details, add. So here you can give different loading patterns, that is whether the loading type is a dead load, live load, roof live load, wind load, seismic load. So different kinds of loads can be, load type can be chosen. Right now in our case this is just a continuous beam and some loads are given there, so I am keeping it as none only. So here I will give them as beam loads, add and close. So select this beam load, add. So primarily we have a 64 kilonewton concentrated load, 45 kilonewton concentrated load and 12 kilonewton per meter uniformly distributed load. So in this we are loading the member, so we will come to member loads. Here this is an uniform force, uniform moment, concentrated force, concentrated moment. So here different type of member loads are given, which we can assign according to our requirements. So uniform force is nothing but a uniformly distributed load, uniform moment is nothing but an uniform moment is applied all along the length of the beam, and a concentrated force is nothing but your point load. Concentrated moment is nothing but the moment concentrated at a particular point. One more load is a linearly varying load. So uniform force, so what is your UDL here? UDL is of 12 kilonewton per meter. It is all along the length of the beam. So select here 12. So no need of changing this, as the load is all along the length. Here take care should be taken that we should give a negative sign so that the load acts in the downward direction. Add this one. So this uniformly distributed load, added here. Now concentrated force of 64 kilonewton at a distance 1 meter from the left support. So minus 64 at a distance 1 meter from the left support. I have added this one. Again, next one more concentrated load of 45 kilonewton at a distance 2 meter from left support. Minus 45 at a distance 2 meter and close. So 64 kilonewton is to be assigned for this one, 45 kilonewton to this beam member, 12 kilonewton per meter to this beam member. So select this 45. So you can assign it by using cursor. Assign. So 45 is to be assigned to, 64 is to be assigned to first one. Click here. So first member got 64. Select this one, second member. Select this one on third beam member. So 2 point loads and a UDL is applied to your beam member. So this is how you can apply loads. So now I have to assign general. I have to give the property for these beam. What is the width of the beam and depth of the beam. So how to give this property? Property can be given here. Go to general property. Here you can define what are the properties required here. So you can define here, define rectangle, T, trapezoidal, whatever may be the type of. So in this we have rectangular, let us assume an rectangular beam. They haven't given the dimensions. Instead of dimensions, they have given values I, 2i and 1.5i. From this, how to find out your width and depth of the beam. Let us do one thing. Fix the width of a beam to 230 mm. Okay, now we shall find out the width of your beam. So they have given we have I is equal to for rectangle B d cube by 12. So let us assume B is equal to 230 mm. So what happens now? I will be equal to 230 into d cube divided by 12. So your d is equal to cube root of 12 I divided by 230. So they have to define I here so that you will get what is the D for first beam. Then next beam, to calculate for next beam, let us take if I is equal to somewhere around some value 2 into 10 raised to 5 mm raised to 4. If they have given, we will solve here, we will get D here. For second beam member, they have given 2i. So what we have to do? We have to multiply 2 into I, that is 2 into 2 into 10 raised to 5 will give you the I value. So using this 2 times of 2 into 10 raised to 5 is equal to BD cube by 12. Substitute and get the depth of the beam. So in this case, what I will do, I will assume the beam dimensions directly. That is, first beam I will assume it as 230 by 300. Next beam as it is 230 by 450. And third beam member, that is 1.5 times of I will assume it as 230 into 375. I haven't gone for in-depth calculation. Only what I am doing, I am assuming 230 by 300 first beam member, second beam member 230 by 450, third beam member 230 by 375. So here depth is equal to 0.3, 300 mm. So this is in terms of meters, so I am giving it as 0.3. Width is 230 mm. Add. Next beam is of 0.45. Add. Another beam is of 0.375. Width we have kept constant. Add. Close. So first beam is of 0.3 by 0.23. Select this beam. Assign to. Next beam is of 0.23 by 0.45. That is 2 times of I. So that's why I am taking it as 0.23 by 0.4. Next is 0.38 by 0.23. All the beam got its properties. Okay. Now save it. Go to analysis and print add. So now you got perform analysis. Close. Analyze. Run analysis. Save this one. So now we are done with the analysis, no errors, no warning and no notes. Okay. So now let us go to post processing, apply, okay. Click on beams and forces here. So this is already selected for bending moment. So now I need to check what are the bending moment values developed over this beam. So I have selected this bending moment. Now go to results, view value. In this I need to check beam results in that bending. So here I need the bending moments. Only mid bending moments you require. Only check this as mid bending moments. Only at ends, ends and mid bending, select this one. If you need only maximum, select this one. So what I will do, at ends and at midpoints I will see. So choose the values. So annotate, close. So now you can see here what are the bending moment that says at midspan and at supports 29, 43. So now come to this 20 at support B, the bending moment developed is 30.16. So what we are getting here, 29.38. A minor variation is there between an manual analysis and your StatPro analysis. Then thereafter at maximum value is 40 and 34 and 26 are the maximum bending moments developed. So here I have not selected maximum bending moment. Let us go to results, view value, beam bending moment. Instead of midpoint I will check it as maximum. Annotate, close. So maximum bending moment is 40.655 in this span. So check here, 40.46, 40.6. Okay, there is a minor variation thereafter. So what is the maximum bending moment developed here? 43.361 at this support. So here we are getting somewhere around 39.46. Okay, now let us see what are the shear force developed. For that one you have to select this and turn off the bending moment values, results, view values, go to beam results, uncheck these values, shear at ends and shear at midpoints, annotate, close. So these are the shear force values, 40.655. So what is your shear force developed? 40.46. So see the diagram, same type of variation of the curve you can see here. Okay, 28, 28.45. So here it is giving somewhere around 27.67. So this is how you can see the bending moment diagram and shear force diagram. Now how to check the deflections of the beam? Select this one and check this. Go to results, view values. In this beam displacement, so mx maximum deflection of this beam is 4.78 mm, 2.92 mm, 0.465 mm is the maximum deflection. In this manner, you can check what are the shear force bending moment developed for the beam. Otherwise, you can go to modeling, double click here, select here shear bending you for particular beam from here to here. This is how the bending moment diagram is developed. So here at support at 0, what is your bending moment? 29.38, somewhere around middle at 3 meters. That is your beam is of 6 meter length. So at 3 meter you have bending moment of 8. Shear force developed at support. At this support is 27.67. At middle it is becoming 17.33, and at another support the bending moment developed is 43.61 and shear force is 17.33. You can check here also by double clicking and going to the shear bending. And what are the deflection? Go to select in y direction. So what is the maximum deflection? Deflection is of 0.465 mm is the deflection for this beam. Okay, either you can check here or you can go to post processing and check the things.